Hello to everybody. It is my pleasure to participate in this conference at a distance, and it's a pleasure for Alberto and myself, and we also we wish to thank the organizers for giving us the opportunity of having this talk. We will be talking about some effect of interpersonal distance constraints in modeling Wayout finding from an exhibition hall. The idea is to outline a case study coming from also the personal experience of ourselves in attending special events as art exhibitions. We have been modeling the exhibition hall where people inside will be moving while trying to maintain some interpersonal distance constraint. We will be using two kinds of tools available for this kind of studies. The first one is a NetLogo. The second one is PathFinder. In the second part of this talk, we will be speaking of the details of the NetLogo modeling. And in the third part, we will be dealing with PathFinder simulations which have been used with Monte Carlo repetitions. And we will be concluding with future research topics and some hints for applying in practice these concepts. The case study is split in two parts. First phase, the so-called pre-evacuation phase, that is the normal state of people visiting the exhibition in the hall. And the second part is the egress phase, that is the emergency state we will be dealing with. The exhibition hall is a simple rectangular plan area with artwork inside, with two exit doors that will be available once the alarm sounds and people will rapidly try to move outside. For the normal state, we will be studying people that move inside, visiting the exhibition, trying to maintain some interpersonal distance while enjoying the event. And for the second phase, the emergency state, the alarm will be triggered, and we imagine that people immediately understand the need of moving outside through the two exit doors available to them. The focus is here on the people and the distancing constraint. For the first part, where we have used NetLogo tool, we will be dealing with a group formed by one leader and 7 visitors following the leader. The second part, where we have used PathFinder for especially the egress emergency phase, the group will be formed by the same one leader and 7 visitors, plus 7 autonomous visitors wandering on their own before the alarm sets. NetLogo is used for the first part, for the phase where people is moving before the alarm sounds, and the focus is on the leader with its group of visitors during the visiting time and the capabilities of the model to capture the essential of the interactions in the group, moving this interpersonal distance constraint. When we are dealing with PathFinder, we will be focusing on the way the tool is capable of capturing the way people move outside after the alarm has sounded. NetLogo first. This is an open source environment that uses specific entities. The very basic entities in NetLogo are the patches, the turtles, and the links. We show here the model settings when we can define the kind of world to be modeled. In this special case, we have the need to model boundaries for the plan of the room, so the side boundaries are solid boundaries people cannot walk through, of course. This means we use a so-called rope-off topology, that is, we do not use a torus topologies, in which case an agent exiting on the right side will immediately appear on the left side again. But we model a real case with solid boundaries as the walls. The patches are used in this study just to describe the environmental space, that is the walls and the plan of the floor, and also the way the environment interacts with the people inside. So we have alarm sounds, the way some doors can be blocked, some other are used as exits, and there is an interaction. Because each patch, that is a square piece of ground over which turtles can move, are essential as they represent the space the agents, that is the turtles, move through. And the links also are entities that are useful in this special case, for instance, to model some personal effect of the agent. In this case, we will be able to show visualizing a circle round for each room space of the turtle. The patches and the turtles represent the world we are modeling. Ticks mark the advancements of the simulation when all of the rules for all of the agents are executed in the current step of the simulation. The model, that is NetLogo, is initialized by designing the environment and the agents. Thus, the input data of the environment deal with geometry and effects, while the input data of the agents deal with the position, the characteristics, and the actions of the occupants. The input data of the environment for the geometry are, for instance, the plane area, the walls, the doors, the archways, and the effects of the environment, the solid boundaries, unavailable doors, exits, alarms, and signals. The input data of the agents deal with the position, so number and spatial distribution, the characteristics of the agents, both physical and cognitive, and the actions of the occupants, that is the positioning, especially the interpersonal distancing, movement to visit, wander, dodge, move out or stop, and the decisions to be made that can be reactive or adaptive. Reactive in response to some previous actions, or adaptive trying to find a better achievement for the subsequent step of the simulation. The basic idea of this study is to use relatively few rules internal to the agents, so to let the system evolve by himself to some state with not too strong a forcing from the outside. The rules depend on the nature of the agents. As for the patches, we are dealing with properties of the environment. So if the space is walkable or not, the pre-alarm and the post-alarm sounding, we have employed a color-based picturing for a quick visualization. The rules for the turtles deal with the breed the turtles represent. That is the leader, the visitor, the wanderers, and the actions involved. Leading or following while moving, moving independently, checking for sufficiently available room around oneself, or checking for obstacles, pointing some target. The rules for the links deal with the characteristic in special room around oneself. Several constraints need to be implemented in the model for the agents. They may be internal and external to their own state. Internal constraints describe programmed or derived biases, such as avoiding obstacles or pointing one target. External constraints describe the effect of the world, such as solid barriers or responding to the alarm. While, in general, different sets of rules are assigned to each group of agents depending on their breed, some constraints are the same for the agents as such. The interpersonal distance constraint that is usually associated with a room freely available for each agent may span from contact, that is practically in touch, to proximity, that is near vicinity. With the use of the links, the room constraint around each turtle is visualized as a halo moving together with the turtle. The distance of the leader with its nearest visitors, that is dynamically variable during the movement, is adopted as a reference metric, but of course other metrics could be also adopted as well. The initial position of the leader is set at random near one artwork, while the initial position of the 7 visitors is set in chosen points, automatically placed, taking into account the relative distance to be maintained. The initial heading of the leader is set to face west, while the initial heading of the visitor is random. The agents are instructed to direct towards their target only if it is in their vision cones, otherwise they start a random walk until the target is detected. 2 social distancing schemes are applied. In the first set, we talk about visit type. In the second, maneuvering type. In the visit type, less attention is paid to maintaining the interpersonal distance. And the basic behavioral rules are assigned and seen by the agent. If I am the leader, if I see my cone of vision, a network, I'll move toward it. But if I don't see any network, I'll move at random until I see one artwork. I keep trace of the distance from me to the near visitors. If I am the visitor of the group, if I see the leader in my cone of vision, if there is no other agent inside my interpersonal distance constraint, I'll follow the leader. Otherwise, I'll move at random a little. If I don't see the leader in my cone of vision, I'll move at random until I catch sight of the leader. In the maneuver type of simulation, there is more attention to trying to maintain the interpersonal constraint distance. If I am the leader, if I see my cone of vision and artwork, I'll move toward it. But if I don't see any artwork, I'll move at random until I see one artwork. I'll try to maintain the interpersonal distance constraint, and I'll keep trace of the distance from me to the near visitors. If I am the visitor, if there is no other agent inside my interpersonal distance constraint, if I see the leader in my cone of vision, I follow the leader. Otherwise, I'll manage to know where the leader is and move a little toward his direction. Some results are shown with runs with NetLogo, where for the visiting time resimulation we see there is some time where the interpersonal distance constraint is not maintained nor achieved. But the results show better agreement with maintaining the interpersonal constraint of 1 meter. We said this one, in these cases, is better when there is more attention in the behavioral rules assigned to have trace and attention to the interpersonal distance constraint set. PathFinder. PathFinder is used here to assess especially the egress phase once the alarm sounds. But now the population is formed by 7 visitors with the leader and 7 autonomous visitors wandering about. The free evacuation phase is set to 10 seconds, and the evacuation phase moves the people to the less distant exit at the alarm onset. 3 primary schemes are adopted with simulating free flow, or social distancing partially constrained flow, or social distancing constrained totally flow constraint. We see the results where the average after several runs are carried, of course, are reported. There is a little delay when the social distancing constraint is more stringent, is more strict. The exit times are shown here in their ranges, and also the way the first and the last out also histograms are also reported. The interpersonal distancing shows here also some cases where the interpersonal constraint is totally followed, and some cases where the people move inside the interpersonal distance. And also there is the count of occupants inside the distance set. This is good for quickly visualizing the end results of the simulations, and especially when using this kind of simulations, we need statistically data that have to be assessed. We use Monte Carlo simulations, and so we were able to capture when sometimes also people get inside the interpersonal distance. But the emergent patterns are well established in the grass phase. We see V-shaped flow formation circling around visiting. Conclusion and future research work here are, with the basic rules described, there is no guarantee that social distancing is respected. We need to include more advanced behavioral rules based on human capabilities. This is what we are working about. In the injury practice, it's recommended to increase the input value for the social distancing, and model input should be calibrated with environmental human-specific data. We have just finished, we have this talk. We thank you again, and I hope this will be useful for future discussion and research about these topics. Thanks a lot from Alberto and myself. Thanks. Bye. Ciao.
Yeah. And I'll check for questions here. Okay, great. So we're starting to get some questions in here. Yeah, so we have one here. Just thank you for the insightful talk. The question is, why did you not use, let me reread, why you did not use only PathFinder as it is capable to model pre-evacuation phase also?
But first of all, we decided to use two kinds of tools because we were deepening both actions deeply inside in the scripts you can do in the tools themselves. So whether, as you have seen, NetLogo has been used for starting to give some insight in the behavioral rules you, of course, have seen. We need upgrading the rules to more significant human capability representation, of course, but we are working about that, of course. And also, if PathFinder can try to manage some way the pre-evacuation time, it was just the first way we, Alberto, myself, and our teams are doing to just work in parallel ways using both one kind of behavioral modeling tools, such as NetLogo that is suited for complex systems, and PathFinder. In the future, maybe we will be also approaching the pre-evacuation phase in PathFinder, even if, as you have seen, maybe I will try to explain now, in 10 seconds, PathFinder needs to model the grouping is a first step to try to understand the way before the grass is starting.
Mm-hmm. Yeah, and I would say that we have some room to improve in that area of more, I guess, advanced behaviors with some logical decision making to say, okay, if there's somebody like you did, like if there was somebody here, they could go there, and if not, go over here. And we don't really have that kind of conditional branching and logic yet in that pre-movement time. So I can see a good reason to use some other tool that can maybe handle that process simulation independently from the evacuation simulation. So that made sense. There was another question here. How did you assess the convergence of results for the repeated runs? Was this based only on time or also on some other variables like congestion levels, densities, etc.?
We started to run several runs, of course, to assess some variability of the results. And as for NetLogo is concerned, we used the metrics, one of the simplest, of course, with distancing from the leader to his nearest visitor during the simulation steps, repeating and with the graphics that were repeated and superimposed one upon the other. And for PathFinder, instead, we use the histograms for the time used during the evacuations. But this depends on the metrics we will be assessing later in this program research.
Great. Let's see, any other questions? I want to also check event and stage chat just to see sometimes people put questions in other chat channels. So, okay. I'm not seeing anything there. Yeah, I thought it was interesting to merge those two models together and kind of simulate the pre-movement time and the standard operational state with one tool, and then that be the input or the starting point for an evacuation tool. So, well, I think what we'll do, I don't see any other questions coming here. I want to thank you very much for participating, and we'll transition back to the stage. So thank you, Fabio.
Thank you. It's our pleasure. Ciao.
Take care.